Okay, so now this is getting a little tricky here. Okay, so F1 is 10.2. F2 is 16.0, right? Okay, so I guess I'm just going to have to, what we're going to have to do here is just do what we normally do. We're going to add these two forces, right? Okay, so let's see. I always have to be very methodical. So this is going to be magnitude. F1 is 10.2. Look, it gets a little darker. That's kind of funny. And then this guy is 16.0. Okay. F1, what is that angle? Geez. Well, if that's 120, then this must be 30, right? Yeah? Okay, so let's see. It would be 360 minus 30, which would be 330 degrees, right? So F1 is 330 degrees. There's our angle. Okay, and then F2 is, well, it's 90, right? That's pretty simple. I don't even need a calculator for that one. Let's see. Okay, so X direction, Y direction. Look, they both look like a X. There we go. Okay, so let's see. F2 is easy. It is nothing in the X direction, and all of it 16 newtons in the Y direction. Okay, and now I'm all set. I'm going to take this thing and go this times cos of that and get this. It should be a positive number, by the way. So 10.2 cos 330. 8.833. They think they have 3 sig figs. I'm going to carry 4. And then I'm going to go 10.2 sine of 330. This should be a negative number, and it should be half of 10.2, 5.1. And that's, of course, because what sine of 30 degrees is 1/2. Okay, so there we go. And now we're going to add all these guys together. So F1 plus F2. I just love that. I wish I could do that on my PC. Okay, so let's see. This guy, that's just 8.833. Right? And then 16 minus 5.1 is 10.9. Why'd I put a Y there? I don't know. 10.9. Okay, so now we are set. The sum of these vectors is this. It is over, up more than it went over, right? Subtly more, and then there's the vector right there. This is 10.9. This is 8.833. The magnitude, the hypotenuse, is the square root of 8.833. Plus 10.9, both of those guys squared. So square root of 8.833 squared plus 10.9 squared, 14.03. That's this hypotenuse right there. Okay, and then let's find this angle right there. Theta equals inverse tan of the opposite side, so that would be opposite adjacent, right? 10.9 over adjacent side, 8.833. Ta-da! Okay, so here we go. Inverse tan, 10.9 divided by 8.833. That's 50.979, so 51 degrees is good enough, right? It's actually 51.0 degrees, right? Okay, so 51 degrees. We've got the newtons, the 14.0 newtons, right? We don't have the acceleration, so let's see. It's a 27 kilogram object. So we're going to say, I'm going to use F equals ma, right? So 14.03 equals 27a. This is the net force, right? I'm just saying F equals ma. So 14.03 divided by 27, 0.5196, so 0.520 is correct. Meters per second squared. Yay! So problems like this, basically, most of the work is just adding the vectors. And then once you've added the vectors, you just use simply F equals ma, right? Once you get that, right? So it's going to accelerate that way.